All right, so today we've been talking about similar figures, and we've already solved a couple. And if we review our definition of similar real fast, it means same shape, different size. And for them to be the exact same shape, that also means that their sides will be proportional. So we're going to solve this one together. These two rectangles are similar. So if they are similar, then also I know that their sides are proportional. So I'm going to start by finding the matching sides. So this 3 centimeter side and this 1 2/10 centimeter side are proportional. And then I also know that this 4 centimeter side and this X side are proportional. And I've set up for myself 2 color-coded rates because I know that the ratio of these 2 short sides is going to equal the ratio of these 2 long sides. So the first one is 1 2/10 to 3, so that's the short side of the small figure to the short side of the large figure, is the same rate as X is to 4. So I'm going to set up a cross product equation. Because it is a proportion, these 2 rates are equal. Then I know if the 2 rates are equal, their cross products are also equal. So the cross product equation is 3 times X is equal to 1 2/10 times 4. 1 2/10 times 4 is 4 8/10. Then I want to isolate that variable. So the inverse of multiplying by 3 is dividing by 3. And 4 8/10 divided by 3 is 1 6/10. And this is centimeters. So that's the side length of my small side of the small shape, the large side of the small shape. Blech. Okay, so let's try the next one. This one says a Boy Scout leader is putting the flag on a flagpole. The Boy Scout leader is 6 feet tall and his shadow is 4 feet long. If the shadow of the flagpole is 10 feet, how tall is the flagpole? So let's draw a picture of what's going on here first so we can see it a little better. So here I have a flag, and the flag, it says, I don't know how tall the flagpole is. That's what I'm looking for. So let's put an X for the height of the flagpole. And then I have a shadow on the ground. It does tell me that the shadow of the flagpole is 10 feet. And then I have a scout leader standing here. The scout leader is 6 feet tall. And he has a shadow, and his shadow is 4 feet long. So because the scout leader is standing by the flagpole, the sunshine is hitting them at the same angle. So I know that the shadow to the height of the person and the shadow to the height of the flag must be proportional. So I can use my colors again to identify the matching values. This height should be proportional to this height, and this shadow should be in proportion to this shadow. So I can set up a ratio, 2 equal ratios the same way. So 4 feet to 6 feet, to 10 feet is the same ratio as 6 feet to X number of feet. And now I'm going to set up my proportion. So again, 4 feet on the shadow to 10 feet on the shadow. So this is the man's shadow, this is the flag shadow. It's the same per ratio as 6 feet, the height of the man, to X, the height of the flagpole. So then I need to set up a cross product equation so that I can solve for X. So 4 times X is equal to 10 times 6. Because if these rates are equal, if they form a proportion, then their cross products are also equal. 4 times X equals 60. Divide both sides by 4. And X equals 15. So So then I can tell that my flagpole must be 15 feet high. And that's reasonable. That's how you're going to use proportions to solve for the missing links on similar figures.